And in this video, I will finish the analysis that I have done with this circuit to show you how to use Ohm's law to get the current that flows in this circuit. So I said before, when I'm moving in an ideal wire, I will make that delta V, that potential difference, to be exactly 0. So what this is gonna give me is the following. V2, now this is, okay, I do want to make it clear, this is theory, okay? What I'm doing now is theory. From 1 to 2, ideal wire, this is 0. From 2 to 3, ideal wire, this is 0. Ideal wire, 5 to 6, 0. 6 to 7, 0. 7 to 8, 0. And I have two terms that survive. Everything else is 0. That's great. Now, V5 minus V4, okay, I go from 4 to 5, so I go to the left, the electric field goes to the right, so the potential increases. That means V5 minus V4 needs to be a positive number, the plus. Now, this is an ohmic resistor. Okay, when I work with a circuit, this is going to be an ohmic resistor, and I can use Ohm's law. The current that flows in the circuit times the resistance. So plus IR plus, because this delta V needs to be a positive number. And I have only one term that survived here. This is the one across the battery. So I go from 8 to 1, so I move to the right. The electric field inside the battery points to the right. That means the potential decreases. If the potential decreases, then I need to make sure that I have a minus sign. And this is the battery. Okay, this is a battery, and typically we use the symbol the term EMF to represent the potential difference across the battery. So this is gonna be minus the EMF, and this is equal 0. That's it. So what I have from Kirchhoff's loop rule is plus IR minus EMF is equal to 0. And here, if it is the current that you want to predict, you can just say I equals EMF over R. If I tell you that I have a battery of 3 volts, the resistor has resistance of 1 ohm, I know that I'm going to have a current of 3 amperes, for example. Okay, one example, a simple one. So this is how you will work with circuits theoretically, and of course this is a very simple circuit. I want to show you what this will look like with using, that's an ideal battery, EMF, that's the resistor. Okay, this is the circuit that I just worked with. The battery, the positive side to the left, the negative to the right, and the resistor. And for this simple circuit, when you apply Kirchhoff's loop rule, you get plus IR minus EMF equals 0. Now, one quick note. I chose this loop from 1 to 2, 3, 4, so I'm moving clockwise in this circuit, and I found this from Kirchhoff's loop rule. What would have happened if I had chosen to move counterclockwise around the circuit? In that case, what you would get is minus IR plus EMF equals 0. At the end of the day, you're getting the same result.